Hi everybody, this is Doug from DMS Systems, and today we're going to go over a little tutorial about using macros in Cisco IOS. I had read about this on one of the blogs that I frequent, and it intrigued me because I had never used iOS macros before. So I thought I would mock up the situation that was actually described in the article and see how they really work. So here's a quick summary of what we have. We have two WAN routers, one of them in San Francisco, which we're calling R1, and another one in Sydney, which we are calling R2. We are actually in Sydney, and we have a console cable connection directly into R2. The scenario is this. Right now, we don't have any policies in place on either one of the routers that would limit on which interfaces they can form neighbor relationships. And our information security department has come to us with a new security policy stating that that is the policy they want implemented, that a neighbor cannot form on just any old interface. It has to be specifically defined in the configuration to allow a neighbor to come up on that specific interface. So in our scenario that we're looking at right here, we can see that the neighbor relationships are on each router are on fast 00. But we have nothing in the configuration that's limiting it to fast 00. We could plug it into fast 01, for example, and the neighbor relationship could still form. So here's the scenario that we're going to do. To make our InfoSec department happy, we are going to use a feature in most dynamic routing protocols called passive interface. And in OSPF, what the passive interface command does is tell OSPF, among other things, not to create neighbor relationships on that interface, even if all the requirements of an OSPF neighbor in a hello packet are met. So here we go. Let's do it first on R2 so you can see what we need to do to satisfy our information security requirement, and then you'll see how we're going to use iOS macros to perform this same function on router 1, even though the change itself is disruptive and could potentially disconnect us from router 1. We'll have to use our imagination here because we're just mocking this up for simplicity's sake. So in this exact tutorial, there would be ways to get around the issue that we're going to use macros to get us through. But if you use your imagination, you can come up with something a little bit more complex or another scenario where this situation would be more true to fact. So here we go. We're going to we're sitting on this laptop right down here. We're in Sydney. This is us. We're going to log into R2, make the changes on R2, see what happens, and then from R2 we're going to use Telnet to hop over. Oh, so that was a terrible line. We're going to use Telnet to hop over to R1 and make the same changes on R1 using a macro. So here we go. Let's hop on to router 1. There is our terminal for router 2. Excuse me. We are over here in Sydney, connected to router 2. So first of all, just verify there is our neighbor relationship with 1.1, which is the router in San Francisco. And if we look at our OSPF configuration, we have this router configured in a newer format, if you will, for OSPF. This is a format that other vendors also support, so it is not an uncommon way to do it. It's a little bit of a step away from Cisco's previous implementations of OSPF using the network statement inside the OSPF clause. So if you look here, well, let's do it this way. Let's just do a show run. When you look at the OSPF router clause in the configuration, we're using routing process 1. Oh, there it was. Okay, we're using process 1. We're setting the router ID And that's all we're doing under the routing OSPF clause. The only other configuration that we have at this time for OSPF is actually up here under the interface FAST00. And if you look at our map, FAST00 is the interface that connects to this router. This is the interface we're running OSPF on. And that's exactly what we're doing. Interface 00, we have an IP address /30 for the point-to-point. And here's our OSPF statement that says this interface and thus this network are going to be in OSPF area 0. Router 1 over in San Francisco is configured the same way. So you can do it either way. You can put the interface itself into the area, or you can use the network command to put this network into the area. Just as a note, other vendors do it this way, and in IP version 6 with OSPF version 3, this is the only way you can do interface. You can add networks to OSPF from my understanding. I haven't mocked that up yet, so I don't know 100% that it's true, but that's the word that I've heard out there. So here's what we're going to do. We've seen the OSPF process. In order to satisfy your InfoSec demands, what we need to do is tell the routing process that you cannot form neighbor relationships on any interface that comes up. To do that, we're going to passive the interface. Now, to do that for a particular interface like FAST00, we would just go under the routing process and say passive interface FAST00. That would stop 00 from forming a neighbor relationship and would actually drop our neighbor. So let's do that as a quick example. We go into the routing process and we say passive interface fast 0/0. That is going to cause our neighbor to go down. There it goes. We just lost our neighbor relationship over to router 1 in San Francisco because we told the routing process that you can't form a neighbor relationship on 00. But we did not tell it that it can't form a neighbor relationship on 01 or 02 or whatever other interface we have on the router. So to do that, let's back this out first so that our neighbor comes back up. And there we have our neighbor back up. To tell it that it can't form a neighbor relationship on any interface, we use the default command. So instead of specifying a particular interface, we say passive interface default. And what that does, we see the same change. FAST00 goes down, but if somebody tried to form a neighbor relationship on any other interface on this router, it would also be denied. Now, to allow our neighbor to form on FAST00, because that's really what we want to happen, we have to say no passive interface fast 0/0. And that will bring FAST00 back up and allow FAST00 to have an OSPF neighbor form on it, but it will not allow any other interface on this router to form an OSPF neighbor relationship. So let's take a quick look at that. There we are. We have our neighbor relationship back on FAST00. And if we look at our router OSPF process, we will see the commands. First will be the passive interface default, which tells it that it cannot form a neighbor relationship on any interface. And the second part of that command right here is to say that FAST00 is exempt from that rule. We can allow a neighbor on 00. And if in the future we need to allow a neighbor on interface 01, we'd have to go in here and add the no passive interface 01 command. Now, as you saw when we did that, it caused our neighbor relationship to drop. And here's the scenario. To make this secure, we also need to do the same set of commands over on our router in San Francisco. Over on router 1 here in San Francisco. So router 2 we just did. Router 1 we have to do. Let's say we're in a situation where we have no one on site or no out-of-band management to get to router 2 to make this change. The only way that it can be done is from us connecting across this internet link to router 1 and doing it from a telnet or SSH session. This, as we saw, is going to cause our neighbor relationship to fail. Now, in this simple scenario, that's not a big deal. We could actually telnet in directly to this interface and make the change. The OSPF neighbor relationship is not necessary in this scenario for us to reach router 1 and make the change. but for the sake of simplicity, we're going to pretend that it is. So, and you can take this concept and expand it to any other process that you may need to do on a router. I found this one intriguing. It was the one that was mentioned in the article, the scenario that was mentioned in the article. I thought it was an intriguing concept, so I wanted to mock it up. But this is just an example of macros. So we're going to go back into our router here, router 2 that we've already configured, and we're going to telnet over to router 1. So now we're on router 1. Now, in our scenario, we need to perform those same 2 steps under our OSPF process, passive default all, and then no passive fast 00. But we're going to do that in a macro because as we saw when we did the passive interface default, we lost OSPF neighbor relationship to the neighbor. And we're going to pretend that that extends to losing connectivity to the neighbor. So to get around that issue where we have an outage or are unable to reach this router that we need to configure, we're going to write a macro to do it for us. And what a macro will do, will execute the steps in sequence whether we are there at the command prompt or not to make those changes. So we're going to go into config mode and we're going to create our macro. So the first step here is to define our macro. So we're going to say macro, and we're going to use the help because there's not a whole lot of options under here. First of all, we're going to say name, and it's going to say give us a name. What do you want to call it? So I'm just going to call this passive def, passive default. That's what we want it to do. Now it's telling us to enter the commands, 1 per line, and then tell it when our macro is over by hitting the @ sign. What I'm going to do at this stage is I'm going to bring in my trusty friend Notepad, because Notepad will let me allow me to enter all the commands and go back, verify, edit them, and then paste them into the config. If I type them directly into the config and I make a mistake, I have to delete my macro and start over. I'm not a very good typist, so I want to make sure that I can edit this before I send it into the configuration. So the first thing we need to do is go into the router OSPF 1 process. Next step was the passive hyphen interface default. And our last step was no passive fast 0/0. And then those were the 3 steps. Go into the router process, do a passive interface default to shut down all interfaces for forming OSPF neighbor relationships on, and then to free up fast 00 so that we can form our neighbor relationship on fast 00. I do not see any typos in here, so what I'm going to do is take this and copy it and paste it into our config. And then of course the last thing was use the @ sign to tell it that we're done writing our macro. So there's our @ sign. Boom. Now let's do a show run so we can take a look at the config. Okay, right. Here's our macro named pass def. Here's the steps we're going to do that we cut and pasted in from Notepad. And here is our current OSPF process, which was just the same as on router 2. Wide open as far as what interfaces neighbor relationships can form on. So what we are going to do is our macro's in there. Remember, we're connected. We're actually on router 2 telnetted across to router 1. Now we're going to execute our macro. And we execute the macro in the config as well. So again, we're going to say macro, question mark, what are our options? Well, it's global. We're going to tell it to go ahead and apply, and then it's going to say what is the name of the macro you want to apply. And we called this macro pass def. Now, when I hit enter, it's going to execute our macro on router it's going to execute our macro on router 1. We are on router 2. So let's see what happens. I think it was pass 2 F's and pass def. There we go. Okay. So it just took a little bit of change. So here what we see is we get a message that the OSPF neighbor has reloaded. We didn't get a down message, but we did see a reloading message. So we're still on router 1, the one over in San Francisco. Let's do a show IP OSPF neighbor. And there our neighbor relationship with 1.2 is indeed established again. And if we do a show run section OSPF, we should see that, number one, there's going to be a command that tells the interface that we want it in area 00, which is under the fast00 interface command. And then here's what our infosec wanted us to do. We said passive interface default on router 1. We know passive router 00 interface fast 00. Even though this caused our neighbor relationship to go down and possibly our connection to router 1 to go down, the macro continued to execute, added this interface as an exception, our neighbor relationship reformed, and we were able to finish the requirement from our information security department. So there you go, just a quick mock-up of using macros. I would look into macros. Well, let me add a couple other things here real quick. Number one, the macro is still in our running config. This was a one-time use of this macro, not a macro that we would execute over and over on this particular router. So we'd want to go back into the config and clean that up and take that macro definition out of the config. Of course, number two is you'd want to save your running configuration so that if this router reboots, InfoSec doesn't make us go back and fix it up again. Router macros on iOS have a fair amount of flexibility. I've looked into some of the other options you can do with macros. You can do wildcards where you don't have to specify an exact interface, for example, but it can be prompted. They're fairly flexible. If you have a task that you need to do over and over again on a router, maybe on a monthly or weekly basis, and it's more than just one or two lines that you can hop in and manually type in and not worry about it, or if you need to make a change that's potentially going to disconnect you from that router, macros may be a good alternative for you. So take a look at it, do a little research, see what you think, and I hope that this tutorial was informative and helpful to you. Take care, everybody.